this video, we are going to dive into a configuration of our layer 3 switch using Ansible. For the topology, I have an Ansible control node connected to the switch I have named Spine, which is the targeted switch I'll be modifying with the Ansible Playbook. Now, I am aware this is not a true spine and leaf topology yet. It is currently a collapsed core, but it is designed to grow into a full spine and leaf architecture as I add more devices to the lab, so that is why I chose to start with the proper naming convention right from the beginning. And as you can see, connected to the spine switch, I have a leaf switch which will be enabling communication to the first two devices in this private network. And that provides a quick overview of the topology. Now let's take a look at the Ansible playbook itself. The playbook, as you can see, it has only two plays. The first play is where the playbook is going to add the spine switch into the inventory to be able to work on it as the playbook runs. The second play, that is where all the magic happens. So in the second play, as you can see, I have 17 different tasks, and each task is going to do a specific configuration on the spine switch. Starting from the top, the first task is going to create 3 new VLANs at layer 2, VLAN 1000, 2000, and 3000. Once the layer 2 VLANs are created, the playbook is going to enable routing between VLANs in this new layer 3 switch. The next step is going to be to change the name from a master switch to a spine switch. Then, after the switch name has been changed, it's going to assign IP addresses to the layer 2 VLANs it created at the beginning of the play, and it will configure the switch virtual interfaces, which is the SVI for VLANs 1000, 2000, and 3000. After the SVI process has completed, the playbook is going to configure 3 different DHCP pools for VLANs 1000, which will be assigned to be the network management VLAN for switches. VLAN 2000, that is going to be the servers VLAN, in VLAN 3000, which is going to be the PC VLAN. After this has been completed, all the devices will be able to communicate with each other. So I've created an ACL, or access control list, to block traffic for VLAN 1000, 2000, and 3000 to access the network 192.168.40.0/24, which for all intents and purposes in this lab, that will be the internet, a network outside this private network that I'm building, and it's also going to restrict any SSH and telnet traffic going out. Next up is going to configure the trunk port between the spine switch and the leaf switch. When I load the configuration in the spine switch, it's going to have no trunk ports enabled in it. So on this task in the playbook, it will configure that trunk port to enable the communication on the leaf switch. And if I expand that task, you're going to see what it does. And it's just enabling trunking in the switch and configuring the native VLAN, which, as we said before, is going to be VLAN 1000, which is a network management VLAN. And then it's going to add to the allowed list VLAN 1000, 2000, and 3000. So when the devices connect to the leaf switch, these are going to be able to send a DHCP request to the spine switch and get an IP address. It's going to run a spine 3 port fast on the trunk, so it doesn't do the blocking, learning, forwarding process of spanning tree, but it automatically just starts passing traffic. And then IP DHCP snooping trust, which is the command line needed to allow the HCP traffic. And then it's going to turn the port on to enable the communication to the leaf switch. At this point in the next process, the playbook is going to look in the spine switch for all the IP addresses that have been given out via DHCP, looking at the DHCP binding database. At that point, since the configuration has just been done, the DHCP binding is going to show 0 IP addresses. But that is just a check that I added for future labs. So whenever the new switch is added, to the topology, the switch is going to send a DHCP request to the spine switch, and then the playbook in this case is going to wait 60 seconds for that process to happen from the time when the leaf switch sends a DHCP request to the spine switch to respond, and the leaf switch to get an IP address from the DHCP scope. It should happen in less than 60 seconds, but I gave it 60 seconds just to be safe. And then after the 60 seconds are up, the playbook is going to check again the DHCP binding database, and at this point it's going to match the results from the first time it ran to the new time it runs +1. So it should be at least one more IP address in the DHCP binding database. And now on the new IP address that is showing in that database is going to check and make sure that the switch has received the IP address. And if something happens, it's going to give us an error message with the result that something happened. After that is completed, it's going to configure the NAT inside VLAN 1000. Once that NAT is enabled, then the playbook is going to configure the destination network address translation, or DNAT, on the outside port and enable port forwarding on VLAN 7 to VLAN 1000. So what this DNAT is translating is the Ansible control node public IP address, in this case the 192.168.40.98, which is on VLAN 7, to the private IP address for the leaf switch, which is going to be in the 192.168.20. More than likely 211, which is going to be the first IP address in the scope that can be given out to a device, and this IP address is going to be on VLAN 1000. So once the packet comes in, it will translate the public IP address from the Ansible control node into a private IP address, and it will do port forwarding using port 23, which is telnet, to allow the Ansible control node to telnet in to the leaf switch. And I use telnet for a specific reason in this lab, and it's because the switch, the spine switch in the topology, it has SSH enabled. To make it easy to follow, I enable telnet. So whenever I'm showing you how the port forwarding works, you can see the difference between the spine switch and the leaf switch. So another way you can look at DNAT is if you have worked on firewalls and you have seen or worked on a DMZ, that's what DNAT is. It is a DMZ in the firewall. And the final task in the playbook is going to be to check all the ACLs, to check all the NAT rules, make sure everything is being added properly as the tasks were going present. And after that, it's going to complete the playbook and it's going to print the results. Okay, and now that we have seen the switch topology and the playbook, let me show you where the IP addressing for this actual lab came from. If you've done any network IP subnetting, you know that it can be time consuming. You have to ensure it's done properly, checking for subnet overlaps, confirming the correct broadcast address, default gateway, and so on. I prefer using smaller subnets or specific CIDR blocks for my labs. So to make this process more efficient, I actually wrote this custom Python script. I spent a good amount of time writing it and confirming its accuracy, but now that it's confirmed to work, it is a huge time saver. I only spent a few seconds deciding the initial subnet, and this script handles all the calculations and heavy lifting for me. But let me show you how it works. So I'm going to open it with Python. It's going to give me this screen, and it's very self-explanatory. When I was writing it, I used a simple subnet as an example, and it's the 192.168.1.0/24. From there, I start testing. So what it does is it's going to ask me if I want to keep this range, 192.168.1.0/24, or if I want to change it, which means that I can use any other range that I want. So for this lab, I selected 2, and I decided that this subnet that I was going to be using was going to be the 192.168.20, And it is implied on the script that it's always going to be a /24. If I hit enter after entering the third octet, it's going to give me the options on the subnets that I can create. And I can create a /25, which is going to give me two subnets of 126 usable IP addresses and a total of 128 in each subnet, and go so on and so forth. So for this lab, I'm going to use 4 because this lab, as I said, it might grow into something bigger. So I want to give myself some room to grow as I add more devices. So I'm going to type in number 4, and there you go. It created 16 subnets for me. And see, it goes from subnet 1 all the way down to 16. And this right here is what I will be using. Subnet 14, 15, and 16. And subnet 14 is going to have an IP address range of usable IP addresses from 192.168.20.10 up to 192.168.20.222. The subnet mask is going to be 255.255.255.240, and the default gateway is going to be 192.168.20.209. And if I go back to the playbook, I'm going to expand the SVI part of the playbook, and you can see where this information matches. You can see the IP address for the default gateway is going to be 192.168.20.209, 255.255.255.240, which match what is given me here. The IP address that is going to be configured for the router is going to be 210, meaning 192.168.20.210, which is the first usable IP address after the default gateway. And with that, I know that the first IP address that is going to be given out on the DHCP scope is going to be 192.168.20.211. And then I have the subnet for the servers on VLAN 2000, and you can see the default gateway is set right here on subnet mask of 255.255.255.240. The first IP address that is going to be given out to the first server is going to be 226, and the last subnet that I'll be using for VLAN 3000 is for the PCs. So default gateway 192.168.40.241, 255.255.255.240. All right, so now that you know where these IP addresses came from and how I use them to configure the playbook, I can go ahead and go to the next part. I'm going to go ahead and load a basic configuration to the spine switch, and I'll load an actual configuration on the lift switch that is going to be the real configuration for this lab in the private network. The basic configuration for the spine switch is going to be a configuration that only allows me to just basically SSH into it so the playbook can run all its magic and configure it. So I'm going to do that next. Okay, and before I start running the playbook, I'm going to preset up the switches in the topology. I'm going to start with the master switch, which will become the spine switch after the playbook has finished running. And also, I will preset up the leaf switch. The leaf switch, however, is going to have a full configuration in it, and all they will be waiting for is to get an IP address from the DHCP scope the playbook is going to create on VLAN 1000. So I'm going to move this up a little bit on the view, and I'm going to open the console connection on the spine switch. You can see the switch has boot up, and on the second view I'm going to open the console connection for the leaf switch. There we go. So both switches have been turned on, they have booted up, and they are ready. Let's start with the spine switch, or as it will be configured to begin with, the master switch. So as you can see, the configuration is a very basic configuration. A host name, the first interface in the switch, which is Ethernet 0/0, is going to be an access port configured to VLAN 7, and that is going to be the WAN connection or the Ansible control node connection. And change that. So I'm going to add the description in this interface as Ansible control node on VLAN 7. The remaining 3 interfaces are going to be shut down. I am creating a username to be able to log into the switch with the playbook. Interface VLAN 1 is going to be shut down. Interface VLAN 7 is the one that has the IP address the Ansible Playbook is going to log into, which is in the same subnet as the Ansible control node. The default gateway and the domain RSA key and the transport input is going to be SSH. So I'm going to go ahead and paste this configuration in the spine switch. As you can see, it says master switch and it's configured. And now if I go and do a show interface status on the switch, you can see that the first interface has the description Ansible control node and is configured to be on 7. If I do a show run, you can see where the configuration that I loaded took place. Host name, IP domain name, username, interface Ethernet 0/0, VLAN 7, IP default gateway, and the VTY lines on transport SSH. So you can see it's a very basic configuration just to allow my Ansible control node to be able to SSH into it and start making the configuration changes that I have set up in the playbook. Okay, so that's the master switch. Now let's do the leaf switch. Now, regarding the leaf switch, its initial configuration, it's gonna be more extensive. And the configuration that I will be loading manually to the switch before the playbook runs includes the setting up of the management VLAN as 1000, as you can see here. Also, a DHCP request to the spine switch for an IP address using that static route for VLAN 1000. I have also pre-configured the first trunk port connecting to the spine switch and configuring interfaces 1 and 2 to VLAN 2000 and 3000 respectively to connect the server and the PC to each one of them. Now, here's a key detail of this whole configuration, and it's the fact that even though the leaf switch has all the necessary SSH settings, I have explicitly set the transport input as telnet. The reason for choosing telnet over SSH here is purely for demonstration visibility during the DNAT process later in the lab. I will be using SSH to connect to the spine switch from the Ansible control node, but then when I connect to the internal leaf switch in the private network via the DNAT, I want to use telnet, and it will cleanly illustrate how the DNAT is translating the incoming connection. So I'm going to copy this and I'm going to paste it in the leaf switch. And there we go. Now it is configured. So I'm going to check the configuration by issuing show run. And now you can see the host name, IP domain name, the HTTP snooping on VLAN 1000, username and password, interface 0/0, which is the uplink to the spine switch, Ethernet ports 1 and 2 for server and PC, the static route to VLAN 10's default gateway for the DHCP request, and the communication to VLAN 1000, and the transport input telnet. Okay, and now I have the leaf switch and the spine switch ready to launch the playbook. And now to run the playbook, what I'm going to do is I'm going to bring my terminal back into focus. And as you can see, I am using a Windows computer, and you cannot run Ansible on Windows, but you can run it on Ubuntu. So what I did on this Windows computer is I installed WSL, which is the Windows subsystem for Linux. I installed Ubuntu, and on my Ubuntu, I installed Ansible. So now that I open my Ubuntu terminal, what I'm going to do is I'm going to go to my virtual environment where Ansible is running, and I'm going to look for the files in that folder. my IPv4 subnet maker, the Python script that I showed earlier, which is this, and the playbook that I called the network builder, which is the playbook that I showed you over here. And to run the playbook, what I need to do is I need to type in Ansible-playbook space the name of the file, which in this case is the networkbuilder.yaml space dash dash ask dash pass. That will ask me for my password to be able to SSH into the spine switch. I hit enter. I'm going to ask for my password. I'm going to enter the password, hit enter, and the playbook has started. And as you can see, as the playbook runs, you're going to start seeing a lot of configuration changes on the spine switch in real time. You can tell what it's doing. It's creating the VLAN 1000, which is what the playbook is telling you that it's doing right here. As you can see, it keeps going through the process, creating VLANs, enabling the inter-VLAN routing, has changed the name from master switch to spine switch, and now it's adding the IP addresses for VLANs 1000, 2000, and 3000, creating the DHCP pool for VLAN 2000, which is the switches, 2000 servers, 3000 PCs, so on and so forth. Here you can see where you configured the downlink port to the leaf switch from the spine switch. Now it's checking for the DHCP, making sure it's getting one on the leaf switch, which is going to be here on the far right terminal, and we should see an IP address assigned to this switch while we wait. And there we go. You can see VLAN 1000 has given an IP address to the leaf switch. You can see keep going through the tasks in a playbook. You waited for the 60 seconds. It looks for the DHCP binding again. It did not find any issues. Kept going with the playbook, and at the end it shows all the results. So it was a successful run. All the tasks in both of the playbooks ran successfully. There are no failed tasks. Everything that it was intended to do, it did. Alright, so now that the playbook finished, I'm going to go ahead and go to the topology and check the configurations in the switch and make sure everything works as it was intended originally. The spine switch has been configured, and you can see here where after the playbook finished running, it changed the name from master switch to spine switch. So that was one of the tasks in the playbook. Plus, I don't have any errors, so all the configuration that I had set up in the playbook was done. So all these 17 tasks were completed with the playbook. All right, the very first thing I want to do is I want to test the DNAT with port forwarding and make sure it worked. I'll check for the IP address on the Ansible control node, and it's telling me right here that the IP address is 192.168.40.98. So what I'm going to do is I'm going to make a little list of the IP addresses that I currently have on this topology. So I have the Ansible control node with IP address 192.168.40.98, this Pine switch with IP address 192.168.40.60, that's on VLAN 7, and 192.168.20.211, that's on VLAN 1000. That's how the leaf switch can talk to it. And now the leaf switch is an IP address of 192.168.20.211, and I know that because that's the IP address that was given to the leaf switch during the DHCP assignment while the playbook was running. So now that I have that information, what I'm going to do is I'm going to test the DNAT port forwarding rule that I set up on the spine switch. So how this DNAT was set up is from the Ansible control node, I'm going to type in the IP address of spine switch 192.168.40.60. This is the public IP address. And once the traffic hits that IP address, it's going to convert that public IP address into a private address using port 2223 to telnet into the leaf switch. So what it's going to do is, from the Ansible control node, it's going to use the spine switch IP address on VLAN 7, and in here it's going to translate the information to telnet into the leaf switch on VLAN 1000. So let's see how that looks. So I'm going to type in telnet 192.168.40.60, which is the IP address of the spine switch, but I am going to route the traffic through port 2223 for telnet. I'm going to hit enter. As you can see, it's asking for the username and password. I'm going to type in JLeo and the password, and I'm in. Now, I want to point something out. As you can see in the leaf switch, there's a log where it said that there was a successful login from a user, converting the public IP address from the Ansible control node into a private IP address inside the private network for the leaf switch. And to make this a little bit more clear, what I'm going to do is I'm going to go to the spine switch, and I'm also going to telnet into the leaf switch 192.168.20.211 JLeo and the password, and I got another log. But let's look at that log up close. If you can see here, the first time I logged in from the Ansible control node, the source was 192.168.20.98, which we know is the Ansible control node. The second time that I logged in from the leaf switch is telling me that the source IP is 192.168.20.209. Both connections are port 23 and made by me. So this is just goes to show that the DNAT is working. So whenever the packet came in from a public IP address, in this case 192.168.40.98 on port 2023, it converted that into a private IP address and translated that into a 192.168.20.211 to allow my Ansible control node to log into the switch. The DNAT is working, port forwarding is working, and now what I'm going to do is from my Ansible terminal, I'm going to enable the ports in the leaf switch. So if I do show interface status, I can see that the ports for the server and the PC are currently turned off. So I'm going to go ahead and turn them on. Interface range 1 and 2, no shut. And I should see ports 1 and 2 coming up on the leaf switch, which I am. I'm going to write into memory, and I am going to exit the session from the Ansible control node. And now that proves that the DNAT is working, port forwarding is working. And now, since I have already shown the connection from the Ansible control node into the private network, I don't think I need to stay on the Ansible control node. So to make it easier to see, I'm going to focus on the screen with the network topology. And now that we have confirmed the port forwarding works, let's see how the devices behave inside the private network. So port 1 and port 2 in the leaf switch have been turned on, but the devices are not currently active. Before I turn the devices on, I'm going to check the IP-DHCP binding database in the spine switch to see how many IP addresses have been given out so far, which it should be just the one for the leaf switch. And it is just the one for the leaf switch. And with that, what I'm going to make is I'm going to make the leaf terminal a little bit bigger, and I'm going to turn the PC on, open the view in console, and I'm going to do the same thing for the server. When you start it, open the viewing console. So I'm going to check the computer first. So I'm going to log in as the root. I'm going to change the name, clear the screen. I'll do the same thing on the server. Alright, so I'm going to check the leaf switch interfaces one more time. And showing is connected, server and PC. I go to the PC. I'm going to check the IP addresses if anyone has been given out yet. There we go. I see the first IP address. This is 192.168.20.242. And if you remember, if I go back to the tool, the PC is on VLAN 3000, and 3000 has a network of 192.168.20.240, and the usable IP addresses are from 192.168.20.242 all the way to 254. So 242 is the first available IP address for the DHCP to give out. Alright, so now that I have an IP address, let's see if I can start talking to the devices inside the private network. What I'm going to do is I'm going to ping the spine switch. You can see replies from the spine switch. I'm going to ping the leaf switch, which is where the computer is connected to. Yes, I can connect to it. And now let's see if I can ping the server. So in order for the PC to successfully ping the server, what is going to happen is the computer is going to go to the leaf switch, from the leaf switch to the spine switch, and then at this point the server should have already an IP address. So all the ARP has already been taken place, which means that the spine switch knows where the server is. So once it gets the packet from the computer, it's going to send it back to the switch, and it's going to tell it port Ethernet 0/1 has the PC, and then the switch is going to send the packet to the server, and it should have a successful ping between the two devices. Let's see if that works. I am in the Ansible PC. I'm going to go to the server and confirm that this one has already received an IP address also. And IP-A, and yes, I can see the IP address on the server as well, and it's 192.168.20.226. I'm going to go back to my Ansible PC, and I'm going to ping that server 192.168.20.226, and it's going to go through the ARP process, and now it's pinging. And yes, I can reach from the computer the leaf switch, the spine switch, and the server. But that is for ping. What about telnet or SSH? So to check that, what I'm going to do is I'm going to VNC into the computer to have a better graphical interface. Open terminal. I'm going to telnet into the leaf switch, which is 192.168.20.211, and credentials, and I am in the switch. Alright, so this confirms that I'm in the switch from the Ansible PC. Now, if I go back to the switch, if you remember from earlier, I logged in into the leaf switch from the Ansible control node, which it was IP address 192.168.40.98 using port forwarding. Then I log in from the spine switch on VLAN 192.168.20.209, and now that I am logging from the Ansible PC inside the private network, you can see the IP address is 192.168.20.242. Alright, so now that I confirm that I can log in from the computer into the leaf switch, I'm going to exit this connection, and I'm going to SSH into the spine switch so I can confirm that I can connect to it from the computer inside the private network. SSH JLEO at and the IP address of the switch, which is 192.168.20.210. Accept the key, enter the password, and I'm in. I'm gonna expand this left window a little bit more so you can see where it's giving me the succeed message on the spine switch. So now that I'm inside the spine switch, I'm going to check the interfaces. I can see the interfaces. So what I'm going to do now is I'm going to change the description in interface 1 that currently has no description. So I'm going to add a description config T, and the interface I want to log into, I'm going to add the description leaf switch. I'm going to do show interface status again, and now I have the description of what's connected to the first port in the spine switch. So I'm going to exit the connection, and so far I know I can connect to the switch using telnet. I can connect to the spine switch using SSH. Now, can I connect to the server from the PC? So in here, I'm going to clear the screen inside the computer, and I'm going to SSH into the Ansible server. And if you remember, the Ansible server IP address is 192.168.20.226. Enter, and yes, I can accept the key to log into the server. Enter the password, and I am in. So that confirms that from the computer I can telnet into the leaf switch, I can SSH into the spine switch, and I can SSH into the server. So according to the playbook, that's what it was configured to do, to be able to do inter-VLAN routing and allow the PC to be able to connect to all the devices either via telnet or SSH for management and configuration. So I know the computer is good then. Everything is fine, it's working as expected. Now let's look at the server. I'm gonna log into the server. Now from the server I know that the IP address that I have is 192.168.20.226. Since I have an IP address, I know I can ping all the switches. The spine switch responds. The leaf switch responds, and also the computer responds. 192.168.20.242, and it does respond. Okay, so that is good. All the devices are able to communicate with each other, which is what I needed with the inter-VLAN routing configured through the playbook. And when the playbook was deployed, there were several ACLs in it where it allowed certain type of traffic and block certain type of traffic. So in this case, the computer was allowed to be able to telnet into the leaf switch, SSH into the spine switch, and Ansible server. However, there's an access control list or an ACL that blocks the server to be able to SSH into any device. So as you can see, I can ping them so the server knows it exists, and I can also ping the server from the other devices. Now let's see if I can SSH or telnet into one of the switches. So I'm going to start with the leaf switch. I'm going to try to telnet to 192.168.20.211. And you can see here it's telling me that there's no route to the host, which is exactly what I needed. Now if I try to SSH into the spine switch, I'm going to do SSH JLEO 192.168.20.210, and the same, there is no route. It'll be the same thing if I try to SSH into the computer, no route. So that tells me that since I can ping all the devices, that means that the server can see everything. And it also tells me that the ACLs configured through the playbook are also applied inactive, which blocks the server to be able to SSH or telnet into any of the switches. I'm going to go back to the PC, and now I know I can ping the leaf switch, and I know I can ping the spine switch. But what about the Ansible control node? The Ansible control node, as you remember, is on the other side of the spine switch. And also, this Ansible control node is on VLAN 7. So the IP address is different, the network is different. From my Ansible PC, can I ping the Ansible control node? If I try that, I'm going to say ping 192.168. 40.98, which it was the Ansible control node. Hit enter and nothing happened, which is exactly what I needed. So what that tells me is that we have a wall here where it will not allow the devices inside the private network to pass the switch. If they try to pass the switch, they're going to be blocked and are not going to be able to communicate outside. Now let's try the same thing from the server. And this is going to be an interesting one. So if I try to ping the Ansible control node, you can see the message is a little bit different. Now, to begin with, I'm getting a message, but the message is not telling me that the connection is successful. It's saying that the packet is filtered. And what this tells me is when the server tries to ping the Ansible control node, the ACL at the spine switch drops the packet. It will not let it go through. So that is the reason why you see this packet filtered. As the Ansible server tries to ping the Ansible control node in at the spine switch, it hits that ACL and that ACL automatically drops that packet. So the server is also not getting outside the private network. And that confirms that my topology is working, all the ACLs are working. But what about the spine switch? So the spine switch at this point is serving the purpose of a router for layer 3 switch, DHCP server, firewall, and DMC. So because of that, it should be able to ping the Ansible control node and all the devices inside the network. I'm going to go back to the spine switch and I'm going to start pinging the Ansible control node. Ping 192.168.40.98 and I can successfully ping. I'm going to ping the spine switch 20.211. Can successfully ping the spine switch, the server, can successfully ping the server, and the PC. And I can successfully ping the PC. So the configuration and the spine switch, like I said, is serving several purposes as router, layer 3 switch for inter-VLAN routing, the HCP server that gives out the IP addresses from the scope the playbook created, is also acting as a firewall where it blocks unwanted traffic to come inside the network or outside the network, and also is working as a DMZ where it translates a public IP address into a private IP address and forwards that packet on a specific port that we set up, which in this case was Telnet. And that's it for this lab. I went over the playbook, what it was supposed to do, the configuration needed to load on the spine switch, and how the private network was going to work after all those changes in the playbook was going to be applied. So everything worked, the playbook worked, the access control list worked, the DHCP scope creation worked, inter-VLAN routing worked, and ACLs worked. So I'm happy with that playbook and how the lab was set up. That is all for this video. Thank you for watching, and I'll see you in the next one.